So here's a Pythagorean theorem problem, just like we saw in the beginning, but it's a direct Pythagorean theorem problem, right? No word problems. And remember, the two sides of the triangle that make up the right angle, which is, it's not shown, but we know it's right there. Those are the two sides that we square and add together. So those two lengths, those two legs are 6 and 8. So we're going to square both of those and add them together in order to figure out whatever this hypotenuse is. And we'll show it with c, because c is usually the letter we use for hypotenuse. And yeah, it would be c to the power of 2. Excuse me. So we'll evaluate these. 6 to the power of 2 is 36. And 8 to the power of 2 is 64. So yeah, we're still going to add those together to get whatever c to the power of 2 is. And let's go ahead and add those together. 36 plus 64 is 100, which equals c to the power of 2. So principle of equality for this one is we're going to square root both sides to make it just c. That's the length of the hypotenuse. And the square root of 100 is 10. Now this one didn't show the units, but remember, if this was like a written type test, you would look for the units and say, well, if this is inches, it would be 10 inches. Or feet, well, feet, okay? But this one doesn't have it, so I'm not going to worry about labeling it. If you wanted to, you would label it in units. But I don't really see the need for that. So c is 10. And just going back to what we talked about in this lesson, this is one of those 3, 4, 5 triangles. We just multiply these values by 2, right? 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is this 10. So if you used the Pythagorean triple, you could, and that would be acceptable actually. But the Pythagorean theorem is really what they want us to use on this.